were to just define what an extrusion is and how it creates a third dimension. Describe how large-scale 3D models, like cities, are created through remote sensing. Define what a prism map is. Describe the advantages of using 3D visualization. Explain how a person can see stereo photos with a 3D effect. And explain the differences between VR, AR, and MR, which is virtual reality, augmented reality. I don't remember what M stands for MR. Okay, so extrusion. This is a map of Boston. It's actually a map I created with buildings and trees in 3D, plus the sea level. I want to say this is current, but the map I actually made this out of was how Boston would look with sea level rise, and all of these buildings are covered with water. So, extrusion. A flat polygon can be extruded into a block representing a building. It also can be extruded and offset to make bridges or overpasses. And it's simply giving a third dimension to an object. Instead of points, you'll have poles, lines become walls, and polygons will become blocks, like all of these buildings in Boston that we see. The key thing to be aware of from the first page of the chapter is that several examples are actually 2.5D, where only one Z value is assigned to XY. So a better description is actually pseudo 3D, because it's not really 3D. A true 3D object contains volume, so you'll have multiple Z values for 1 point. Most of the 3D things you see right now are actually 2.5D. That's fine. So large scale 3D models. We are going to try the video thing again because I have a bunch of videos to show you. Now there is a setting to share computer sound. Awesome. So this should work, or, you know, just not. There it goes.
Almost 50 years ago, Apollo 8 left Earth for the moon. While in orbit, astronaut Bill Anders decided to take an unexpected photo.
Oh my God, look at that picture over there. There's the Earth coming up. Wow, that's pretty. Hey, don't take that, it's not scheduled.
Later named Earthrise, the photo captured our planet in a way that it had never been seen before. And while the 240,000-mile trip to get to that vantage point was, I'm sure, amazing. I mean, if you ever get that offer, take it. If you don't have a spaceship and 3 days to spare, lucky for you, all you need to do is click a link to get almost the same view in about a second. This is the Earth, all 196.9 million square miles of it.
Google Maps is for finding your way. Google Earth is about getting lost. Google Earth is the biggest repository of geoimagery, the most photorealistic digital version of our planet. We're trying to create a mirror world so people can go anywhere.
From mountains to cities to the bottom of the ocean. Google Earth has been around for about the last 10 years, and just like our Earth, it's been evolving over this time. The imagery has been getting better and better. I was really curious to know, how is Google Earth created? How many images actually make it up? And where do they come from? Last year, together with Lo, I met up with Gopal and Kevin to find out.
So how do we build Google Earth? The way it starts is we look at places that we want to collect in imagery, and then we collect it through a variety of different ways. One is satellites, and satellites give you the global views, and that's all 2D imagery that's wrapped around the globe. When you get closer to the ground, we have 3D data that we collect from planes.
Yes, you heard right, planes. I'd always assumed that every overhead photo of the Earth I'd ever seen was taken by satellite. But I learned creating 3D imagery requires special conditions. So Google flies planes, or as I now like to think of them, street view cars with wings.
What are some of the challenges that you guys had?
The biggest challenge in doing something like this is weather. Our preference is always to have clear skies.
It took us a really long time to get London because we had to fly over London a lot before we got a fully cloud-free image of London.
Come on in.
Nice.
Kevin told us that a typical flight to take photos is around 5 hours. Except the planes aren't going across the country, they're making little zigzags over the same area.
So it's north and turn south. It's sort of like mowing the lawn.
This pattern helps the photos overlap, and multiple cameras help capture a place from different angles.
In planes, we have 5 different cameras, one looking down and forward, back, left, and right.
In my mind, I'm picturing photograph, 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 photograph.
Yep.
And then something puts them all together. Something called an algorithm.
Photogrammetry, yeah.
Which is just a fancy word for taking all of this imagery that we collect from the plane and constructing a 3D model.
The first step to creating a place in 3D is a little bit of photo editing.
So all the imagery is sort of prepped. That would be removing clouds, removing haze, color correcting. You'll actually see that a lot of the cities don't even have cars in them. We actually take the time to extract those.
Then the 3D science begins.
The big breakthrough that's happened in the last few years has been the introduction of computer vision. The computer looks for features within the overlapping images that are the same. We use a special GPS antenna that allows us to know where that camera was. So we know roughly where things were taken and at what angle.
And this allows them to create a depth map.
And that's just our understanding of how far the things are from the camera. And we take all of these various depth maps from the different cameras, stitch those together in what's called a mesh, which is basically a big 3D reconstruction of the place, and we texture it. And texture it is applying the photography that we took to the sides of these 3D buildings. It's almost like taking pieces of paper and cutting them up. You can actually extract the edges of something and then stitch those together and then understand what that shape might be. And organic shapes are what's hard to render. It gets even more complicated when you're talking about trees, because trees have branches and leaves, and often you might see them as a lollipop because that's as good as we can get. But we're getting better at modeling those organic shapes. We did a collective Yosemite National Park, and we were able to actually capture that in really high fidelities with all the different bends that a rock face might have.
Do you know how many different images make up what I see as Google Earth?
Yeah, it's probably on the orders of tens of millions. One interesting stat is to look at what we call Pretty Earth, and this is the global view. So we have a full seamless image, and that comes from about 700,000 scenes from Landsat. And what we're doing is we're finding the best pixel from each. So if you look at Google Earth, it's springtime everywhere.
To be precise, an 800 billion pixel spring globe, which is so big, if you wanted to print that out on your home printer, you would need to find a piece of paper the size of a city block.
If you took a single computer, it would take 60 years to process that.
And you can just keep multiplying this times all the different levels of zoom that exist in Google Earth, which are over 20. So even though using Earth feels like one seamless world that you're just zipping around, it's really more like you're traveling through a series of Russian dolls, all made up of puzzle pieces.
I think everybody else wants to know, how often do the images get updated? It's the number one question.
We try to update it as often as possible. The image all the way from space, when you're looking at the whole globe, we try to update that maybe once every couple years. As you start to dive in, we update that imagery more and more frequently. So for big city populations, it'll be under a year. What that allows you to do is look at how the planet has changed over time. And we use this product called Earth Engine that allows you to look at all of this data and using computer vision, draw out insights from the things that are changing. So we can track deforestation in the Amazon because we can see how the trees are shrinking and growing. And then from that, we can generate a heat map of the most logged places on the planet. We can also do that with fishing and see the most overfished areas. Think about it as a health monitor for the planet. Watching these cycles happen on the planet, you realize that this is a living thing, and the product we're building has to be a living thing to reflect that. You know, it's not a static planet. It is fully alive at a macro scale, and that is very eye-opening when you're actually watching the things change right in front of your eyes, when you have that perspective to see that.
Thanks for watching, and if you haven't played with Google Earth recently, I highly recommend this new feature they just launched called I'm Feeling Lucky. You roll the dice, and then it teleports you to a random spot in the world. Also, to give you a heads up, in the coming weeks, we'll be diving deep into VR, including Google Earth VR. So there's that to look forward to. Okay, that's all from me. Bye.
Okay, so that was a little bit about large-scale 3D models and how Google Earth stitches together Landsat images to create this 3D Earth, really. So let's move from 3D models to prism maps. Prism map is a simple 3D map created by extruding polygon shapes on a map, which are the prisms, to a height specified by a value associated with the polygon. For instance, this is a map of Ohio, I think. And it possibly is broken up by county. I'm not familiar with Ohio that much, but from what it looks like to me, it's a map of Ohio that is broken up by county, and the each prism is probably population value for that county. You can see the red ones are taller, so they assigned both a height and a color to express that more people live up by the Great Lakes than elsewhere in the state. Well, and there's that red one in the middle. The county boundaries are extruded to the height value of the population. We can actually do this in ArcGIS Pro. We are, however, not going to do it today, just for time. You can also apply a vertical exaggeration to the entire scene so that it makes a more polished prism map. Artie? Hey, what are you eating? Oh, you have food on your nose. Can I help you? No? Okay, well, dogs. So let's move from prism maps to the advantages of 3D. So the advantages are enormous. From 3D to 2D, you can do things like urban planning. You can see, if you did Lab 13 already, you can see how a viewpoint can be obstructed by something. You see this a lot in wind power planning. When they propose a wind turbine, they will show from different viewpoints how you would see it and how the landforms might block being able to see it versus how it might block a pretty view. Stereo photos, like the little red viewfinder toy that some of us had as kids. This is actually not the best image because the background is just this sample paper that comes with the glasses, but it does show you the glasses. Yes, different elevations, right? It's almost like you're there for 3D images. So underneath these glasses, you would usually have two side-by-side ortho photos, so aerial imagery, and you'd be able to see the elevations. My eyes could not do it in the lab. It was the craziest thing. I have astigmatism in one of my eyes, and I think that has something to do with it. But when I looked through the glasses, I could not get the image to go 3D. It's like those magic eyes. You might remember the magic eyes that used to be on the back of cereal boxes. I don't remember where else they were, but I could never get those to work either. My eyes just don't focus that way. My brain is broken. So this is what it looks like. Now, you don't see them much. It's kind of antiquated technology. Most things are digital. But it is pretty cool to know what that looked like. So if anybody asks you, how did they see 3D in the past? You could say, oh, well, there were these glasses. All right, now, let's talk about virtual reality, augmented reality, and mixed reality. Yes, okay. So virtual reality is the use of this stereo effect, like this past image, where your eyes see slightly different things and they overlap to create a 3D. The stereo effect for virtual reality is being transmitted through a headset. So if you've ever played with your phone and downloaded something like Google Cardboard, which I had planned on doing in class, and that would have been awesome, and you didn't put it in the VR headset, you just looked at it on the phone, you would see that there were two images side by side that were slightly different. And when your brain overlapped them inside that VR headset, it would make it look 3D. But virtual reality is super cool because when you move your head, the imagery will also move. So unlike a 3D movie, which only shows one direction, virtual reality shows a whole bunch. Well, a lot of the ones I've seen, you could do a full 360 view around the whole environment. Some of them will have a gap in the sky or in the ground where your feet are or whatnot, for the most part. It's 360 degrees around you. So augmented reality and mixed reality also rely on a headset to transmit images, but they use computer-generated images superimposed on the real world. If you've played Pokemon Go, you're already familiar with AR. So there's a fine line between augmented reality and mixed reality. Mixed reality allows computer-generated objects to be anchored to real-world locations, and you can interact with them. For example, utility pipes buried underground. They can be superimposed on a headset to see the pipelines in conjunction with your current view of the street. You actually see this sometimes in medicine now. A lot of those medical TV shows will have a virtual simulation. Please, oh, the back door is closed. It's cold. A virtual simulation of their actual body that they'll be working on, and they can practice doing surgery virtually or augmented. So 3D visualization of geospatial data is advancing rapidly. So being able to quickly turn a set of overlapping photos taken from a drone into a 3D model is very straightforward today. With the growth of the headsets, like Google Cardboard is the cheapest version. There's also more expensive ones. You can actually get them at Five Below now, the cheaper ones. Let's watch this video.
You are watching Cold Fusion TV.
Hi, welcome to another Cold Fusion video. This video is part of an ongoing series in collaboration with Upload VR. The series will cover the emerging technology of the VR and AR industry and what it means for the world we live in. Virtual reality and augmented reality. They seem to be hot buzzwords which we've all heard before. But what are they exactly, and what's the difference between them? In this video, we'll take a look. Let's start with VR. In simple terms, VR is a computer-generated simulation or replacement of one's environment. For example, you put on a headset, it blocks out your world view and substitutes a digital world that's designed to fool your senses. From the point of view of your brain, you're somewhere else. It's a form of mental teleportation, if you will. So where did VR come from? There's going to be a full video on the history of VR, but the basic gist is as follows. The origins of VR as a technology system can be traced back to 1962 when filmmaker Mort Heelig created the Sensorama. It was an arcade-style cabinet with a 3D display, vibrating seat, stereo sound, fan, and scent producer. One of the experiences was riding a motorcycle down the streets of Brooklyn. The viewer would have a 3D view of the streets while having the wind blow in their face, while simultaneously feeling the vibration of the motorcycle seat and even experiencing the smells of the city. Although it was absolutely revolutionary for the time, the idea largely didn't gain traction. Most people point to MIT computer scientist Ivan Sutherland as being the godfather of VR displays. In 1968, he created the Sword of Damocles, the first VR headset. He and his colleagues at MIT started the first virtual headset experiments. As a side point, Sutherland was a low-key genius. He also invented Sketchpad in 1963, an advanced software for computer-aided design and a breakthrough in human-computer interaction. But more on this in the full history video. It wouldn't be until 1987 when the actual term virtual reality was coined. The term was the brainchild of Jaron Lanier, an American computer philosopher and computer scientist. Let's break down the actual meaning of virtual reality. Virtual means being something in effect, though not in actuality or in fact. This is from mid-15th century English. So in other words, ideally, VR is an approximation of our reality that is digital, but not reality itself. Since its inception in the late 60s, VR hardware has existed largely in university research labs in hilariously big and bulky forms, never to test the waters of mainstream consumer product, but more for an understanding of the limits of our brain's perception systems. It was also a helpful tool for PTSD and cognitive behavior therapy patients. Over the years, various companies such as Nintendo and NEC have tried bringing VR to the consumer market, but these efforts were major failures. The reasons for the industry's previous failures will be looked at in future videos, but broadly speaking, the technology just wasn't there and the threshold for building a convincing headset was too high. Until now. Currently, VR is quickly becoming extremely relevant to gamers, 3D artists, architects and real estate agents, teachers and students, and even astronauts. After crying wolf a number of times, VR is finally showing some promise this time around. Okay, let's move on to augmented reality. Augmented reality, also known as mixed reality, is a different beast from VR. This is because its main purpose isn't to cut out the real world and transport you to another one, but rather it's to be an enhancement of your real world with a set of magical virtual objects in it. When a person's real environment is supplemented or augmented with computer-generated images, usually motion tracked, then that's augmented reality. So if you played Pokemon Go when that was a thing, or have used Snapchat lens face filters, then you've already used primitive forms of augmented reality. Here's another day-to-day but fairly amusing example of augmented reality from a third-person point of view.
The roads have been cleared. We're ready to get back out on the roads. Let's bring this car out actually into augmented reality and show you what I'm talking about. Because you hit the roads are clear, visibility looks great, right? You think there's no problem, but then you get behind this guy. You know, the one that doesn't clear the snow and the ice off.
The term augmented reality is attributed to a former Boeing researcher, Thomas Caudell, in 1990. Augment is from the Latin word augere, which means to increase or to add. Hence, AR technology is adding to our existing reality. Currently, augmented reality is also showing promise with efforts like Microsoft's HoloLens and the very secretive Magic Leap project. So let's take a quick summary of both technologies. Virtual reality tends to be completely immersive with no real-world stimuli affecting the experience. The goal of VR is to make the user feel as if they are, in fact, in another place. In stark contrast to this, augmented reality acts as a digital addition to the user's world. For example, objects can appear on tables, information can be displayed in floating windows, and graphics can be generated, all seamlessly motion tracked to the user's field of view. The thing that makes AR and VR different from any other forms of technology is that it directly affects the perceptions and processes of the human mind in an obvious way. It's the only technology that can provide actual packaged experiences. While there are a large number of people that do think both AR and VR are a fad that will fade out like previous hype cycles of the technologies in the 80s and 90s, the thing to note here is that the underlying technology is vastly more powerful this time round and is very much feasible. Think of it as a time that's parallel to smartphones just before the iPhone. We just need the right blend of killer AR and VR applications, product, price, and consumer demand to really begin the altered reality spark. At current rates, by 2025, attractive AR and VR experiences will be commonplace. If done right, these technologies show incredible potential. Thanks for watching, guys. This was just an introductory video, and there'll be more videos coming in the series with Upload VR. Rest assured, plenty of...
Okay, so that video went over VR and augmented reality and gave you some additional information. I'm gonna have to watch some of these later. So, what are your questions?